Good morning, everyone. I hope you can hear me well. I hope you can see the screen. Okay, thumbs up. Very good. Thank you. We're also recording the meeting or the webinar, so we can share it with you and anyone else interested. It's all public thing here. And we also have shared the link to the report based on which we are doing this webinar now. Just a short introduction. It is part of the INTERRFACE project, but it's not only about this specific project, because I would say it's one step in a long journey. So we already have a follow-up project going on, which is called the OneNet, and which Jan will talk about a bit more later. But this journey is all about the flexibility market. It's about the regional concept of the flexibility market involving Finland, Estonia, Latvia, but also Lithuania in the new project, in the OneNet project. And therefore, we have invited the stakeholders from all these 4 countries to be part of this. And what we have been doing is really to set up a kind of joint concept and joint processes, products, tools of a harmonized flexibility market for this region. And just to show you the agenda before we go to the first presenter, this is how it looks like. We will have 2 hours in the end. We hope to have quite some time for questions and answers session. But before that, we do individual country level short insights. Also, we will have a more technical presentation by Cybernetica. We will have next steps by Jan, as I mentioned, but we will start with Nikolaos Pelidis from European Dynamics. So this company, and specifically himself, has been the coordinator of that project. So I will ask Nikos to make the introduction to the project as such, but also focusing on the main output, main result of the project on high level. So please, Nikos, you can take over here.
Thank you, Kalle. So good morning from my side as well, and thank you for joining and for being here. So my name is Nikos Bilidis, and I work for European Dynamics, and we are the coordinators of this INTERRFACE project. So I would like to quickly introduce the project, what we are doing, what we have been aiming for all those 4 years, and give some insights, and before we move to the more specific presentations. So INTERRFACE is a 4-year research project funded under the Horizon 2020 framework. The INTERRFACE stands for TSO-DSO Consumer Interface Architecture to provide innovative grid services for an efficient power system. The project started almost 4 years ago. We are running the project activities will be concluded in December of this year. And we are happy because one of our biggest assets is our very wide and extended consortium, which brings together 43 partners from 16 different countries. It's a very heavily industry-driven consortium, which covers the whole energy value chain, including 7 transmission system operators, 8 distribution system operators, European Association, which is ENSOE, 1 regulator, 1 market operator, and 9 service or technology providers, and 10 research centers and universities. And of course, 1 international organization, the Florence School of Regulation. The main vision of INTERRFACE was to bring together all energy stakeholders to allow their cooperation and coordination, and to facilitate market integration processes, adopting new products and services in a standardized manner, and coordination schemes for system operators, and also to enable interoperability and transparency. To this end, we have created the EX architecture, a platform which is which aims to share data among all participants in the electricity system value chain, from local, regional to the whole EU level, which enables TSOs and DSOs and customers to coordinate their efforts to maximize the potential of distributed energy resources through a transparent market mechanism that allows the participation of more actors and favoring at the same time the smaller consumers or prosumers, and also leading to the unlocking of an important flexibility potential. IEXA serves the main objectives of the project, which can be summarized in the following. So the project aims to create this common architecture, as we said, to define and demonstrate standardized products, market designs, and coordination schemes, to integrate small scale with large scale assets, which aim to increase the market liquidity in different levels of the market, and also for grid services, and to facilitate the scaling up of new services at the pan-European level. Also to drive the collaboration in the procurement of grid services by TSOs and DSOs, enabling the incorporation of locational information and also the grid conditions, to improve market signals that so that we can increase transparency and create strong incentives for connected customers, and to facilitate market processes such as the actual bidding, the qualifications at different levels, the activations, and the settlement. The project features 7 large-scale demonstrations that have been implemented in different parts of Europe, covering versatile power systems and countries, where the electricity markets feature different levels of maturity and national particularities. This allowed us to test the various concepts that we have and solutions that we have developed in Interface in really versatile environments, and to ensure the applicability across Europe. So the demonstrations cover 9 different countries and 3 different thematic areas. As you can see, demo area 1, congestion management and balancing issues, peer-to-peer trading, and pan-European clearing market. Of course, today we're focusing on demo area 1, and more specifically on the single flexibility platform demo, which was deployed in Finland, Estonia, and Latvia. And now let's move on. So the main product of the Interface project, as I already mentioned, is the interoperable pan-European grid services architecture, the IEXA platform. The core functionality of the IEXA platform lies on certain architectural components, which will be presented later. These architectural components facilitate the provision of services and the implementation of processes which lie on the business layer. As you can see here in this SGAM-based representation of our platform. The powerful data management middleware that lies in the background in the information and communication layer facilitates the data exchange that is essential for the implementation of the business logic. And finally, the standardization through the adoption of the common information model and other well-known standards ensures the interoperability and the scalability of the proposed solution. Here we can see the main processes that are facilitated by IEXA that lie on this business layer of the SGAM-based architecture that we saw before. So IEXA covers grid qualification through custom and automated algorithms that promote the TSO and DSO coordination. We are adopting the traffic light system, and we also support the direct involvement of system operators, allowing the coordination through well-defined coordination schemes. We also support product qualification, which is aimed to ease the qualification processes for market operators. We are covering the trading process and the bid qualification, again, through automated algorithms, taking into account the desired level of coordination between the system operators. And by gathering the qualified bids, IEXA can issue merit order lists for different markets or for combinations of markets. We are also supporting activation by allowing the system operators to directly activate bids through the EEXA platform, and the synchronization with the markets allows to keep track of the activations in different systems. And finally, the settlement. We support the energy settlement by adopting and hosting common settlement, custom settlement algorithms. And through this, we are able to calculate imbalances and to see the result of the energy settlement. So these processes are facilitated by the main components of EEXA that lie on the function layer. We have the flexibility register, which allows, gathers and shares relevant information on potential sources of flexibility, enabling the seamless connection of flexibility service providers, allowing them to bring their flexibility products to the markets, and allowing them to perform an efficient portfolio management. Then the TSO-DSO coordination platform acts as the gateway for the system operators and allows the exchange of data and the coordination between the system operators, and at the same time allowing them to procure in a common and coordinated manner system services, resulting to a more efficient and resilient and economic operation of the system. We have the single interface to market, which is a gateway and point of connection of EEXA to the different market platforms which are interconnected, and the settlement unit, which is responsible for performing all settlement calculations. Of course, all these are complemented with a user management module that supports different kind of roles, and each role has its own rights and responsibilities, and logging and reporting for analytics and for statistical analysis. So that's all for me. In the following presentations, we will highlight the demo application and the main results in the 3 different countries. And we will provide insights on future endeavors and opportunities that are already underway. So I give the floor now to Jukka to present the Finnish case. Thank you.
Yeah, thank you, and good morning from my side as well. I'm Jukka Rintaloma from Fingrid, and I will be presenting the Finnish demonstration and also some TSO perspectives to that. But since we have 2 presentations from Finland, so I will be giving more general overview, and then my DSO colleague Antti will continue with some more detailed information after me. So first of all, starting with the big picture of the Finnish demonstration. So the main goal was to pilot the end-to-end process of EEXA. So we wanted to verify the new concepts. So there are many novel ideas that we wanted to test. So the starting point was, it was important to verify the concept itself. And the demonstration that focused quite a lot on TSO-DSO coordination. So that was also something really highlighted, and Elenia, our DSO, and ourselves as TSO, so we provided the different simulated grid models that we then used to test the processes themselves. And those situations that we used, these kind of grid models, so they were based on realistic grid needs that we envision that we could see in the future. So at the moment in Finland, there's not that clear or not frequent congestion, so not the kind of situations that we could use, but these are kind of, that's why we used simulated grid data to actually then kind of access these future envisioned grid needs. And the Finnish Baltic demonstration, our group was really active in the project to develop this TSO-DSO coordination functionality. So that's why it was also in the core of our demonstration to test how it functions. And then the market perspective. So in our demonstration, we connected 2 market platforms to the EXA system, and we focused the congestion management. So we used the MFRR market and the intraday market, and by connecting this locational information, we could use that for congestion management. Yes. So then next, I have some kind of example how we applied the EXA architecture to implement the testing. So in this figure, this is kind of simplification of the components and roles that Nikos already shortly introduced. So this is kind of the building blocks used by the demonstration, and also here you can see how different parties took the roles that were needed. So here you can also see that in addition to the partners of the Finnish demo, we also had 2 external parties to kind of get more content to the demonstration. So we had Capacity.io. They received the cascading funding from the project, and they acted as a flexibility service provider. And also we had Nordpool. They also joined the project to test to connect their intraday market platform to the system. And if I shortly then present kind of the main processes, so you get the picture how the demonstration itself went and what kind of roles and functions different parties had. So starting from the flexibility service provider. So here we have the FSPs, and their task firstly is to manage the resource information on the EXA side. So the flexibility register is managing those. And after that, they're able to participate to the markets. So basically they interact with the 2 market platforms to do the kind of the flexibility trading. And we have the two options during the pilot. And then again, on the other side, we have the system operators. So we provide the grid data that acts as a basis for the TSO coordination or the qualification of the bids. So those role of the system operators, and then through the market platforms and then to EXA. So we were able to access the bids and again activate them as we needed. And then this information goes through the market platforms back to the FSPs, which again then communicates with the actual resources to activate them. So this is basically the big picture how the EXA enables this kind of architecture we have, where we have many market platforms and many system operators using the flexibility offered by the flexibility service providers. And also what I didn't yet mention was the metering data, which is then sent by the FSPs to EXA, which is then used for the settlement process. And here I can mention one interesting thing that came up during our demonstration. So since we used 2 market platforms, 2 products, so we piloted this kind of concept where we bring bids from those 2 market platforms to one merit order list. So we simultaneously saw both bids coming from both markets, so we could kind of use both of them and kind of at the same time. So there was this kind of merging of two market platforms, which is kind of interesting concept in a sense that in the future, if we want to streamline the process, so we use many market platforms offering the bids and then making it easier for the system operators to use them. So this was an interesting concept, kind of what we tried during the piloting. Then, as an example for the demonstration scenarios that we use to do the end-to-end testing of the system, so they're listed here. I'm not going to go through them in detail at this point, but we had different kind of these scenarios that we could see emerging in the future, and So basically they were mostly focusing on congestion management, but also in the beginning we tested the functioning of the system, so kind of getting these use cases for kind of partial activation and then short activation of the bits, and the rest were different kind of congestion management cases. And you can see the kind of detailed description of these from the report that we shared, and also you can find the link from this slide later. And also to give an example how we managed to do the end-to-end testing, so we used the resources of Capacity.io, the cascading funding partner. Here's an example of the metering data that was gathered by Capacity.io from one of the cases. So that's how we were able to conclude the end-to-end testing when we also had these actual activations from real resources. So they used heat pumps from different locations to actually conduct the activations that were coming from the demonstrated process. Here's still the link for the deliverable where you can find the details of the different results or these scenarios. And then finally, some lessons learned from the demonstration. So the project from our point of view was successful in creating the firm basis for flexibility markets. So when the aim was to enable and also foster this market-based flexibility procurement, so it was really important to then understand what kind of building blocks and new structures are needed to implement that in the future. And also, like I said, the TSO coordination, that was a big part of our demonstration. So for that also we gained understanding of the different methods that we could use to actually conduct that. So in the following presentation you can see more about the approaches, but just testing that was important to open the possibilities that actually for the technical implementation there exists. And at Fingrid we also tested on our side how we could provide the input data needed for the TSO coordination. So how we use our current systems, current data to provide the input data. So that was also something that we were able to learn during the project, that how we actually can then come up with that data. So how to create the actual grid models used. So from my point of view, that's important also to show that these the EXA, the systems or the coordination model, that's actually implementable or exploitable in the future. So we actually can create the input data needed by the process. And finally, the last learning maybe to highlight was that we found out that actually congestion management is doable with the existing marketplaces. So what was enabled by the EXA architecture was to combine the physical world or the actual resources, their location to the market process, to enable not only to use them for congestion management, but also the coordination. So connecting the market process to the physical grid, that was possible and tested in the demonstration. And also when we use the existing market platforms, I would still like to comment that more that already today there are really a big variety of marketplaces, and many market actors, they already say that there's too much, and we try to have that kind of idea that we would like to increase or at least to maintain the liquidity on these markets by not fragmenting them even more. So using the existing markets. That's kind of really important from that perspective. And then also this system allows to increase the number of different marketplaces or products in the future. So, for example, now we from the current products or the reserve products, we tried the MFRR, but also the others could be added in this architecture in the future. So that was a short intro to the Finnish demo and TSO perspective, and next we move on to the DSO perspective.
Thank you, Jukka. My name is Antti Mutanen, and I present Elenia, the second biggest distribution system operator in Finland. We have been very glad to participate in INTERRFACE project. Our vision is to be a responsible reformer of electricity services and markets, and this matches very well with the INTERRFACE goals. For us, one particular area of interest has been the TSO-DSO coordination, and I will shortly present what the project has developed and how it was demonstrated. The main goal of TSO-DSO coordination is to avoid situations where TSO flexibility activation causes or worsens overloadings in DSO network, or vice versa. To enable TSO-DSO coordination, we have developed a two-stage coordination process where we first perform grid pre-qualification for flexibility resources, and then later do a bid qualification. We have also devised 3 alternative methods for doing the qualification. These are power limit-based qualification and network sensitivity matrix-based qualification. These 2 methods are centralized processes performed inside the TSO-DSO coordination platform. But there's also a third option where the qualification is done outside of the coordination platform, meaning that the calculations related to the qualifications are done in the system operator's internal systems. However, this third option was not demonstrated in the Finnish demonstration. So, grid qualification. The first stage of the qualification process is called grid qualification, which is a preliminary qualification for determining whether or not simultaneous activation of all flexibility resources can cause issues to system operators in the worst case situation. The results of the qualification are shown using the traffic light principle borrowed from the active system management report. If flexibility resource activation never causes any problems to the system operator, the resources are given a green light, and their activation is always allowed. However, if the resource activation can, even in some rare moments, cause network congestions, the yellow light is given and the qualification status is changed to qualified with restrictions. The nature of this first qualification stage is informative, providing flexibility service providers and system operators information on the possible limitations in flexibility resource activations. No unconditional restrictions are made in this stage, so the red traffic light is not used at this stage. Also, the grid qualification is repeated every time new resource groups are added to the flexibility register, and the analysis is done using worst case loads and normal network configuration. Later, in the second stage, we then are able to observe the situation more closely when we are more closer to operating hour, and we know better what is the expected network switching state, how the loads are forecasted to behave, and what resources are actually participating in the markets. we can do a more accurate bit qualification. And this bit qualification determines whether or not simultaneous activation of all locational flexibility bits submitted to the market can cause issues to system operators when activated at their scheduled time periods. In this case, there are two possible outcomes. The bit is either qualified or not. If the simultaneous activation of all bits would cause problems, then bits are filtered out starting from the most expensive bits. The not qualified bits are removed from the merit order list shown to the system operators in EXA, meaning that the system operators cannot activate these bits. Okay, this was shortly the principles of grid and bit qualification. And next, a few words about the implementation. First, we started from the simplest possible qualification method, power limit tables. In this method, the system operator sends to the TSO-DSO coordination platform a simplified network topology. In the case of a DSO, it always starts from the metering point and always ends to the TSO-DSO connection point. And in between we can have various key network components with various degree of accuracy. In our case, we decided to model here low voltage fuses, distribution transformers, and medium voltage feeders, and primary transformers. And for all of these components, we had then also the limits for available free capacity for both directions, up and down. And this information was then shown in a table. This is where the name of this method comes from, because the information can be shown in a simple table format. But actually, this information was sent to the TSO-DSO coordination platform as a JSON file. And then inside the platform, then comparisons were made between the flexibility volumes and these limits. In Elenia, we built some degree of automation for compiling the power limit tables, but quite quickly we moved to developing and testing a more precise qualification method, which in this case was the usage of network sensitivity matrices. We utilized not only PTDF matrices, which tell us how the network power flows change when the node power injections change, but also sensitivity matrices that tell us how the node voltages change. This node voltage aspect of network congestions could not be taken into account with the earlier power limit tables. So this is an addition here. With these sensitivity matrices, we were able to do fast and accurate grid and bit qualification. Granted, it is a bit complicated method, but it has plenty of room to grow. In this project, we barely scratched the surface what we can do with them. Further utilization could include, for example, cost-reflective bit rejection during bit qualification, value stacking, and global optimization. On the downside, the sensitivity matrices need to be recalculated and resent to the coordination platform every time the network switching state changes. And also, we need the network limits, as in the previous method, and the starting point for our calculation. In case of bit qualification, the starting point would ideally be the short-term network state forecast. However, this forecasting still proposes a challenge for the present utility information systems. We demonstrated this TSO-DSO coordination using both of the previously mentioned qualification methods as part of our Finnish demonstration, where we went through the whole end-to-end flexibility procurement process. The TSO-DSO coordination performed as expected, and congestions stemming from excessive flexibility activations were avoided. We used this simulated demonstration network, to which we combined measurements we got from the actual flexibility activations. This approach was necessary to ensure safety and to enable scenario-based testing. We tested how flexibility can support distribution network during times when backup connections are used, during battery-enabled islanding, and during excessive PV generation. Then to the lessons learned. What we learned from the demonstration is that Elenia and other DSOs need to develop capabilities for probabilistic network state forecasting. We need this for providing more accurate information for TSO-DSO coordination, but also we need this to be able to forecast the bottlenecks in our own network so that we can determine when and where and how much flexibility we should procure. The demonstration taught us that uncertainties in state forecast and flexibility supply should also be accounted for. For example, in one scenario, flexibility failed to fix congestion because the congestion was worse than was originally forecasted. And in one case, congestion would not be fixed because flexibility service provider could not supply as much flexibility as was procured. Of course, improving estimates on flexibility availability is something that the flexibility service provider should do and improve. But even so, there will always be some degree of uncertainty in the amount of flexibility that will actually be supplied. So the DSO should be able to take that into account. Finally, when using heating load-based flexibility as the heat pumps that we used in this demonstration, we should consider also the cold load pickup. In one scenario, the forecasted congestions were avoided with flexibility activation, but the cold load pickup caused that the congestion occurred on the following hour. So that must also be taken into account. So these were the lessons learned from the DSO perspective. I'm sure the following presenters will supplement this from other points of view. This ends my presentation. Thank you very much.
Thank you, Antti. And indeed, we're moving on to Estonian now, and I will do it on behalf of Estonian team. So the team was not only the Elerinks team, but we also had Elektrilevi as our biggest DSO in Estonia, and we had Fusebox. So Fusebox was not really the formal partner of the project, but they kindly contributed to the testing as an FSP, the flexibility service provider. And of course, we had many other partners who you have been listening to today already or will be listening. So this is rather like the business side partners for Estonia who tested the solution and who should be the future users of the solution. So in Estonia, we tried two flexibility products. One is the MFRR, which is the existing and well-known product. The other was the congestion management, which is not existing yet. But then also we had a third trial, if I may say so. So this is called flexible contracts or flexible grid connection contracts. I will have a few lines about each later. The solution or at least part of the solution, was tested with the independent flexibility provider, as I mentioned. And the main goal of testing probably was the data exchange. So therefore, the data interoperability and standardized processes and models, profiles for data exchange, these were the core. So this is something also Nikos presented in the beginning and Marco will do later on. So the standardized data exchange was really the key to enable the interoperability also on the business level. And the data needed to be exchanged between different roles, between different systems, either new or existing. So there that was the main target, and that was a challenge we, I guess, managed to address. The two products, I put them on the single slide, and this is very intentional because actually the aim was and still is, we continued this in the OneNet project, was to develop kind of a joint product for both needs. So the ideal goal is to come up with a product or even several products, because you can have like closer to real-time products or more long-term products. But all these should ideally be usable for different needs, for balancing, for congestion management, and maybe even for voltage control in the future. So in that sense, the approach was similar. So the scope was very similar. The steps we developed and tried included resource registration, resource group building, bid submission, merit order list creation, activation order sending, activated volume sending and settlement. Maybe the only difference and the main difference of congestion management compared to the MFRR was that now we really need the grid data. Antti already gave a very detailed insight to that, what is needed, why do we need it, how it is used. But we need the grid data because we need to know where to activate the flexibilities to address the congestion issues. But also on the other side, we don't want to create further congestions. We don't want to worsen the situation. All in all, I can say that also we are satisfied, and everything we planned was, at least to some extent, demonstrated and successfully demonstrated. Of course, the level of ambition is always higher, but this is what we take with us to the next project, and we'll reach the next level really. The grid data, I have a dedicated slide here for the grid data because it is important, and it is something which is conceptually quite new to our existing flexibility market. So the grid data may include different things like topologies, node limitations, energy flow estimates, the PDDFs, those sensitivity matrices, as Antti explained. And we simulated a grid in Estonia together with Electric Levy. It's based on the real situation, but in a way anonymized here, for which we used the data and for which we developed a scenario about how the congestion can occur in this grid segment, and how it can be how can it be addressed with a flexibility usage. Flexible grid contracts. So this is maybe not exactly comparable to the other products, but still it is a measure to how to use the flexibility in the grid, and again to address the congestion situations. And we simply tested it based on the two existing flexible contracts we have. We tried to put the available capacities, the available flexible capacities of these contracts together with the other flexibility offers, so the free flexibility offers. In terms of data exchange, it worked. We could exchange the data. Well, rather there are some business side questions to be settled. So, for example, what is the price of these flexible capacities really, or what is the balancing responsibility of the holders of such grid contracts? Some general observations. So we do have the existing solutions, but they obviously are not sufficient because the increasing number of flexibility providers, resources, we are going to the very end customer level, to the very residential level of the flexibility. So it needs different kinds of processes, different kinds of tools. We do develop the new products, so it's very different from the current situation. Also, the EU environment is changing. New network code being under the discussion. We already know, and we're part of those discussions. And therefore we should be pretty flexible with what we do here. So we should be flexible in the sense that we should be prepared to change our approaches, but without changing the concept of the process. And I already mentioned, which is really crucial, is that we should be able to use the same resources, meaning through the availability of the common products, to use the same resources simultaneously for different needs, for example, balancing and congestion management. But this, of course, will increase the complexity of grid impact assessment. And to summarize my intervention here, again, from Estonian side, the lessons learned, or some of the main lessons learned. I kind of said that the processes we have developed, the solutions, also the products we are proposing here in this project, they can be and should be still fine-tuned if the new business requirements appear. Secondly, we need more sophisticated approaches for the grid impact assessment. Antti contributed a lot to that part in this project, but we are looking into it further in the OneNet project, where we will use this concept not only for grid impact assessment, but also for the optimization and for the value stacking. Going into more residential field, or also other end customers, it means more and more data and more private data specifically. And we need to go beyond the normal main meters. We need to go to the sub-meter level. So the data availability and calculating the baselines for those resources is a key, another key. And related to that, because it is private information, consent management mechanisms need to be in place. They need to be safe. And to finish, again, with the importance of the data exchange, future standardization of the data exchange is needed. We are referring to the SIM, so this is the common information model. It's the standardized data model increasingly used in the electricity domain. So we should move to those standardized approaches, and this is what we also tried here in the interface, and we'll do it in the OneNet as well, to support the interoperability, and not just for like technical data interoperability, but in the end it should support the business interoperability to really create the harmonized regional flexibility market. This is it from me now, and we are now going further south to Latvia.
Yes, thank you, Kalle. I am Ivar Sikmans. I represent Latvian Transmission System Operator AST in the project, and in the project only Latvian TSO is represented. So in the demonstration, the goal was to test end-to-end process of IEXA, of this platform that we're currently discussing, from the start, basically from user creation, flexibility, resource registration and qualification, and up to market trading and settlement of said flexibility resources. And this goal was covered by various scenarios and additional tests. In this testing, we were testing both MFRR flexibility reserve product as well as congestion management product. And the goal for MFRR product was to understand its compatibility with current MFRR processes, and goal for congestion management was to fill gaps of MFRR scenario, as well as to see how to maintain system stability. And during the testing from AST, we used combination of real and simulated data for network and market data. In this slide, I wanted to highlight for the following slides some of the color coding. If you look at the figure in the middle, this is with blue color, this is the IEXA, this platform we're discussing. And on the outer edge, as red and green squares, we have external communication, which in this case represents AST communication. And first data to look at from data exchange would be grid data. Grid data consists of network topology as well as limits. And here the red square represents DSO network data, which due to lack of DSO involvement is test data and basically is scenario based. And on the other side, this red square represents the TSO data, where we had an automated tool to provide real network data of 62 substations, which theoretically could be power flow limited. And this information was provided for the platform based on the historical data available. Next, for the trade data, we have trade data consists of market bids, market bid activation, as well as merit order list. In the figure, we can see again two red positions. This again highlights automation tools, as MFRR market does exist. Therefore, we wanted to make the demonstration closer to real life and provide the platform information of the bids as well as the activations for processing and testing. And this process was supplemented also by test data to simulate further scenarios for the MFRR, as well as to test congestion management, which does not have a market. And last for the data exchange would be settlement data, which consists of activation, confirmation, as well as metering data. And here, similarly as before, we have red square for automated information related to real market information and activities. And we have red squares representing test data provided basically for additional testing and for congestion management product. Next, regarding scenarios. The aim of MFRR scenario was to understand the compatibility with current MFRR processes. And for this, few scenarios here are presented. One would be partial activation, which means that in the market, not all of the provided quantity of the bid would be activated, or the duration is under market time period, which is 1 hour. And this was possible to do. Next would be activation modification, meaning that initially we request one size activation, but we can correct it afterwards. And this was tested on the market side, basically by giving the IEXA platform the information of the latest activation request. So this was possible to do. And lastly, we wanted to test also in the lower table the continuous reliability of IEXA platform, and in the table below there's an example of month-long continuous test, and basically we can see that the platform is quite capable of the data exchange. More than 4,000 messages were exchanged with the platform within this month, with 241 messages exchanged maximum on a daily basis. However, it also highlighted the 2.3% of unprocessed messages, which just indicates that there's a need for a small future development. But in general, the system is quite capable. Next, for testing of congestion management, this was the aim for this was to fill the gaps of MFR, what wasn't covered, which mainly consists for FSP, basically service provider resource management, and additionally to understand how the platform would help to maintain system stability with its congestion management assessment. And moving on to scenarios, the first one, multiple resource registration, up to 20 users were created. Next, large FSP portfolio with up to 100 resources registered in individual user portfolio. And these two highlighted basically the FSP management, and this performed with ease. So there is no issue here to support this. Next scenario, FSP resource modification outside of grid limits. This means that the registered resource in the platform would cause network congestions, and this kind of resource was possible to register in the platform, but it was labeled as restricted. And this ties up with the next scenario, which is this, which is FSP market bid outside of grid limits, meaning that a potentially congestive resource is provided to the market, and thereby the platform does not allow it to participate to maintain system stability. Here, of course, these two these two scenarios are quite good to basically maintain system stability. However, the issue that was highlighted here, that the information for the FSP should be more explicit, how much of their resource could be used due to current network congestions. And this is a small future improvement needed. First to last scenario is FSP resource modification, where after providing a bid to the market, the said resources used in the bid are modified. And what does the platform do is remove these bids. This is a good functionality because these bids no longer represent the assets that were initially provided, and therefore could cause congestions and thereby needs to be resubmitted, which involves qualification of said bids. And the last scenario was to understand, continue basically to understand how the TSO-DSO coordination would perform. And this was already done in the market activation phase. And here we understood that basically you could cause congestions if you activate enough bids. And this just highlighted that we should continue TSO-DSO coordination not up till basically the bids are available in the market, but also in the activation phase, which is also need for maybe future development. And in the very end, I would like to go on with the conclusions. The project provided valuable insight and the basis how flexibility resources could be used and participate in the market. And more importantly, how TSO-DSO coordination could be achieved. But additionally, I wanted to highlight some of the highly beneficial functionalities as well as future improvements. So one of the highly beneficial functionalities would be this help with the FSP portfolio management. This is something that currently locally does not have an alternative and would be very beneficial with aggregation. Next, manage grouped distributed resources, which again is regarding the aggregated resources, which will be a challenge to handle in the future. And the solution provides wide support, as this was already presented by other demonstrators, to allow these resources to participate in the market, as well as to maintain safe participation in the market, causing no network issues. And this kind of ties up with the next benefit of maintaining TSO-DSO system stability. And last highly beneficial functionality would be this new service, congestion management, that has a future potential. Yes, and regarding future development needs, here are a few highlights that I already mentioned before, but this is a summary. First would be that the data processing should be slightly improved to reduce the percentage of unprocessed messages, although at current stage, this unprocessed message percentage is quite low already. And next would be that TSO-DSO coordination should be extended also in the market bid activation period, basically in order to keep maintaining the system stability and this coordination process. And lastly, FSPs need to be quite well informed about how limited their resources are due to network constraints. This would help with the transparency, as well as this would make them understand basically that SOs do not want to intentionally limit FSPs without a valid reason. And well, with these benefits and these developments, I would like to say that these are basically to be considered, as my colleagues mentioned, in the OneNet project and its developed solution. Yes, this would be it from my side. Thank you. Give the floor to Marko.
Thank you very much. My name is Marko Vetran, and I'm representing Cybernetica from Estonia. Cybernetica is a technical facilitator for the regional demo, and we are working together with Eurodynamics, who have created the EXA platform. I will speak a little bit about the single flexibility platform technical solution. So what is single flexibility platform? This is a tool that is aimed to show and demonstrate for potential flexibility market participants to show that the entrance barrier is not so high. The software itself is a very capable way to demonstrate it, so it is very visible and everybody understands it. The tool covers flexibility market operations that were defined by our partners, that was thought to be relevant. And we are using EXA platform that was common for very many regions of European Union, with several customizations and the specific tools that were relevant for our region. So I'm going to speak about that later. The software is going to implement the business processes. The business processes are here aligned in the meaningful sequence. The first steps are qualification steps. So we are taking several steps to qualify resources according to proposed grid topology. We are going to qualify the products. So this is user interface based, and we are qualifying the bids. The bids qualification mechanism was spoken by Antti more thoroughly, but the software solution is going to deal with that as well. Then about the trading process, the trading is happening based on merit order lists. The system operators can pick the set of the bids that they are willing to use. The system is capable to do that by user interface, but we have also API for system operators to send the bids and then make the bid selection available through the API. And then the activation process, and finally the settlement process that is going to make the verdict, what kind of resources were actually launched, and what is the level of the activation in the real world. The single flexibility platform functional diagram is based on three main pillars. One is a flexibility register that is mainly meant for flexibility service provider data. So this is resources and resource groups. Then the system operator is going to face the DSO coordination platform. So here we are retrieving the grid topology information and creating the merit order lists. And the third one is a single interface to market functionality group that is interacting with market operators. That is dealing with the beads and passing information about the bead activations and also about the settlement. So this is a bit more detailed view on the software architecture. Here are represented also the main actors. We have DSO actor here, market operator. We have balance responsible party as well that is receiving the settlement data, and of course the flexibility service provider. So the software itself is based on common EXA platform, but I have marked here also regional customizations and the special tools that we have implemented. I would like to start with the consent management, not consent management, but consent tool that is needed to access the data from the data hub. As the flexibility service provider can aggregate data from very different physical persons or some other juridical persons, then those consents are needed to access the data from the data hub. For Estonian demonstration, we are using Elering's STFEED consent management system. So this is embedded into this interface system, and this is tied together with EXA platform. Then we have resource qualification methods that are qualifying the resources against the grid topology that we are retrieving from the DSOs. Also the bead qualifications, as it was spoken previously, the bead qualification is happening that way that we are applying all the beads on the topology nodes, and then we are looking at the network limits, and we are going to take out the most expensive beads from the setup and then look if the network limits are matched. So this is happening that way. Then we have the settlement units. The settlement unit is capable of working with two methods. The first one is to understand if the flexibility service or the resource was activated based on the past hour load. So we are actually comparing the activation period against the history. And the second method is baseline methods. We are asking baseline from the flexibility service provider, and we are comparing the new situation where the flexibility resource was launched compared to the baseline data. And then we have implemented special semantic conversion tool for market operator Nord Pool. We are transforming the install SIM profile data containing beads to the Nord Pool semantics containing orders and order activations. Yes, that is what I wanted to speak about, the software. The software technical side, the architectural stack is modern, microservice-based system. We are using Java, Spring Boot, and Spring frameworks. And for the hierarchical topology data, we are using Orient database, that is the graph database, that is making qualification queries to be more convenient and to make the software itself more simple. And of course, the SFeed software development kit for the LRINC demonstration. The interface project beads matching is based on the merit order list, and this is right now maintained by system operators visually from the list. As a next step in one project, we are trying to automate that much more, so we don't have any intervention from the person or make those human affected decisions. So this is all automatized by intelligent algorithms. And this is it. I will pass floor to Jan Segerstam for next steps. Thank you.
Thank you very much. So what we'll be looking now at is what happens then. So we are basically going into the next steps. So flexibility is really, really important, and it is important on many, many levels, even beyond the technical needs of networks on which we have based the work in Interface. And combining the needs of the market and the technical needs is something that should be done and also has been done, both in the demonstrator here and will be done more in the upcoming demonstrators of something called OneNet, which I will introduce later in this presentation. So what we did was that we demonstrated the capability of working with different kinds of flexibility on different kinds of marketplaces. And we were able to work with that based on DSO requirements and TSO requirements. And that's an important first step in going forward to adding more countries, adding more capabilities, and deepening the collaboration between different kinds of markets and different kinds of products being traded. Because it's in the benefit of the entire market to have all flexibility available. The flexibility is available when everybody knows that it's available. And that's why the component called the flexibility register that was created in the Interface project is needed also when we set up markets for more flexibility, because then we can share the information about the flexibility with everyone who needs it, rather than having to redefine it for each use case separately. Now, for the users, of course, then you need to work with products, and you need to work with what you actually want from the flexibility. And matching all of that, that's what markets do. They match supply with demand. But then matching the technical requirement with the capability is something that networks need to do, and that's something we do in the TSO-DSO coordination platform. So as we established the base building blocks here in the Interface project, we've now gone on to something called OneNet, basically joining together more countries, bringing on more functionality, and going deeper into what should all of these things do? How should we actually work with flexibility? In the meantime, the work done in Interface has already spawned work within the different member states on regulation on how to enable flexibility to be part of the playbook. Networks have not always been able to make use of flexibility. So the legislation that requires networks to consider flexibility, that has already been passed during the Interface project, and each member state is now in the process of implementing that legislation and implementing the process of getting flexibility online. Now that will take some time, and there are many phases to that, and you should follow the national footsteps in each country to be online with that process. But it's also something that's working in line with what we're doing now in the project called OneNet. So OneNet is a 3-year project, and there's a set of logos over there with a number of different companies participating, and we have taken it to another level. We're 72 partners. We have 23 countries working on flexibility, working on making the network work together, and also making sure that we latch on to liquidity. That's something that we're doing in what we call the northern demonstrator of the OneNet project. So building on the experiences of Interface, where we saw, for instance, in Jukka's presentation that we had collaboration with Nord Pool, we had collaboration with endpoints, and then we saw in the subsequent presentations how all of this worked as a process and what we used for that. Now we're taking that a notch further by adding partners, adding markets, and adding capability. So the key point in OneNet is that we have TSO-DSO pairs. And from a Baltic perspective, we also are now incorporating our Lithuanian friends. So we're not only talking about Finland, Latvia, and Estonia, but we're also talking about Lithuania. And then we are adding also capability from our Swedish friends at Vattenfall. So we're bringing on a large customer base and an understanding of how the different aspects of the retail market and the different aspects of having a large customer base and different kinds of portfolios comes into play when we think about working with flexibility. So we're kind of making sure that the concepts we developed are actually scalable and bring us forward in our quest towards having flexibility available for everyone. So what kind of environment are we looking at? So we looked a bit into the technical details of the interface demonstration with Marco. But if we take the flexibility environment onto a bit more abstract level, we can see the key components here in having the coordination platform where the TSOs and DSOs can come together to ensure that flexibility can be used to the benefit of the system, to really allow the market abstraction to exist and the market to flow as freely as possible. Then we need to interface to the different kinds of markets and buying portals of the TSOs. So we have the AFRRs, MFRRs, we have the energy-based markets of the intraday, for instance, and we have congestion management. So there's different kinds of places where we are already trading. And of course, seeing as this is a competitive market, there can be other kinds of markets. There can be local markets, there can be area markets, there can be competing energy markets. So making sure that assets that are available through those markets are available also for the flexibility is important. That's something that we're doing with the building blocks here. You see the central function of the flexibility resource register, the flexibility register where you register the flexibilities and their capabilities so that the trading becomes easy. All you need to have is the ID that you get. You register your asset, you get your ID, and with that ID, you can go to any marketplace which is connected and trade just the way you would without the ID, so that your normal energy trading on the energy market abstraction works just fine. But using the ID, you can then identify where you are by just sending that ID, which is then deciphered by the TSO-DSO coordination platform to give the TSOs and DSOs knowledge. Oh, it's there. That's where it matters. I need this. And therefore, they can then latch on to that flexibility while not requiring the different market parties to build new kinds of functionality, new kinds of interfaces for each and every product that they would have to enter into using in a situation where you'd have very, very specific markets. So we're trying to bring all that together in one net, really making it one in terms of the concept, even though, of course, there's multiple platforms, there's multiple countries, and there's multiple areas and so on. So it's always a matter of being realistic and going into the real processes of the TSOs and DSOs and the real commercial implementation of markets once we're past the demonstrations. So what we're seeing is that member states are now implementing flexibility more than before. And of course, the energy crisis is at the center of this. So obviously, interest has been raised much more in the ongoing year. And that also then goes for the kinds of flexibilities that we're talking about in these projects. That said, there are already multiple marketplaces. So when we think about flexibility, please activate yourself. Now is the time better than ever to actually connect with the TSOs and sometimes even the DSOs where there's an active DSO market. And of course, then the normal marketplaces of the intraday and the regulating power markets and everything else that you see in your member states where you can already make a difference with the flexibility. These flexibilities will make the difference in the energy crisis, and the functionality brought on by Interface and now OneNet will enable that flexibility to carry the market abstraction even further and enable the market to work to its fullest extent and for all flexibilities to be available for the good operation of the European energy system. In order for the European system to work, we do need to have the regulatory framework in place that allows this to happen and enables the growth of the flexibility to actually happen. And that's ongoing. So please do be active in the discussion with the regulators, with the national bodies and TSOs and DSOs, so that there's a rich discussion and there's a rich capability of embracing the needs in each member state and the special circumstances of the national energy systems of the different countries. The Nordic and Baltic states are in kind of a special situation here. We've already done decades of work together in bringing our energy systems together, and we're sharing a physical market, for instance. That's something that's not so common elsewhere. And we would like to be the forerunners again in making sure that flexibility is handled in a way that can be handled in multiple countries in an easy way. So these things are the things that we're working with in the Interface project, and we will be working with in the OneNet project. So the next steps are within OneNet and within the actions of all the national collaboration bodies that are available. So that's it for me, and I'm turning it over now to the questions and answers session. Thank you very much.
Thank you, Jan, indeed, and thank you all speakers. So we are done with the presentations, and we are open to your questions or comments. You can use either chat for that, or you can raise your hands so we can unmute yourself. There are, I think, 2 questions in the chat now. Both are from Vito. So Vito is a very good partner to us in the OneNet project. I see that first one is to Antti. So Antti, if you are so kind and can answer this question from Hannibal.
Yeah, so Hannibal is asking here, how does the traffic light-based qualification process take into account all possible combinations of flexibility activations to measure their grid effects? Does the approach look at the worst-case situation where all resources are activated concurrently? And my answer to this is twofold. In the initial grid qualification phase, we do indeed assume the worst-case situation where all resources are activated simultaneously and the network loading situation is the worst possible. However, in the second stage, grid qualification, which we can argue is the most important one, we take into account only those resources that are participating to bidding. And in this case, we can also take into account the activation time period, the exact level of activation, and ideally also the forecasted network loading situation in case of the worst case situation. So this is more accurate, and the more accurate information the system operators can supply to the TSO-DSO coordination platform, the more flexibility we can enable, because we are no longer using the worst case situation. And finally, I may also add that in both qualification stages, up and down regulation are studied separately, meaning we don't mix flexibility made to different directions. In theory, more flexibility could be allowed if the simultaneous activation happen, but this is very unlikely, so we don't take that into account.
Thank you, Antti. Hannibal, would you like to follow up maybe? I can, just in case you would like, I can raise your hand and I can unmute you.
Yeah, thanks,
Okay.
Kalle. I couldn't unmute myself before, that's why I couldn't comment. Yeah, thanks a lot, Antti, for the information. Maybe one quick follow-up. So if we look at a setting, for example, where in the second stage that you're looking at, you have a set of upward flexibility bids that you could use, and you want to make sure that none of them or any combination of them, if activated, is safe for the grid. So if you look at a certain set of bids, each one of them have a certain maximum level. The possible combinations that one can look at of possible cross activations between them is combinatoric. So we can have an exponentially growing number of possibilities that not all of them can be taken into account. As what the approach was that, let's say for the upward flexibility bid, we just look at the upper limit of all those bids and assume their concurrent activation and take that in the qualification process, which is the worst case scenario, like I meant in my comment. Or do we look at any other possible combinations that could arise, or other possible concurrent activation levels that could arise in the traffic light concept process?
Yes, also in the bidding stage, if the bid has been made to the market, then all of these bids are taken into account during the bid qualification stage. And the only combination we are looking at is the combination where we activate everything. And if this causes any issues, then we remove bids one by one, starting from the most expensive ones until there are no longer any issues to the network.
All right, sounds great. Thank you very much.
Thank you both. And then the other question is to me from Luciana. So Luciana is asking about the flexible grid connection contracts. So currently, at least, there's really no market for those. So it's rather the last option you put here. It's rather rule-based. So it's the obligation of the grid connecting parties to flexible if requested by the system operator. And but this remains to be figured out if these kinds of contracts can be somehow merged with the so-called normal flexibility product. So can the flexibilities from these contracts be in the same list or compete with the flexibility beats through the normal flexibility products?
Yeah, Kalle, can I ask one follow-up question?
Sure.
Did you bring these flexibilities into the merit order list shown in the IEXA?
Because we did it like 2 years ago, we took them into the merit order list, but I'm not sure anymore. I don't remember if we did it on the IEXA platform itself or we tested it somehow internally. But this is what I cannot recall anymore.
Thank you, Kalle, for your answer. So just to follow up, it's contracts, but there is a payment, so remuneration to the flexibility providers for this, even though it's a mandatory provision or not.
Yeah. So again, if any of my Ellerin colleagues is here and can correct me or complement my answer, but the thing in Estonia is that, well, we don't have, as far as I know, we don't have any specific remunerations for those activations, but the benefit for the connecting parties is rather through the less grid connection payments. So we in Estonia, we have like for the generators, we have the deep connection fees. So this is the way they can escape from those high fees.
Okay.
But that and the what we see now that the need for such contracts seems to be increasing because we are facing the congestions now, for example, connecting the solar generation, even on a very small scale, micro scale. So this is where the flexible contracts could be used and could be promoted more as they are now.
In Belgium now we have it for the inverters of the PV, and they have to provide mandatory system services to the system, and now they implemented it remunerated, so they get something back from the service they provide, even though it's a mandatory provision.
Yeah.
But okay, so that answers my question. Thank you very much.
That makes sense. Okay. So does anyone else have a question or comment? I don't see anything else in the chat, at least. I don't see also any hand raised. Does any one of the speakers have a final word? Hannibal, yeah, you're almost a speaker now.
Perhaps one other question. I don't know who can answer it, any of the SOs, but probably Elenia can maybe answer that. Because I was looking also at the associated report, and I saw that there was also that representations that were given in the report. And I was wondering if the PTDF calculations for those are made public anywhere or whether they are confidential. I think the question would go to Antti as well.
Yeah, Antti, go ahead.
Yeah, in the report we have reported the testing we did, but the actual, if you mean like the PTDF matrices, those are not public because that basically contains network information. So we keep that inside the project.
All right, sounds good. Thank you.
Yeah, I think just the right time then to move to the last slide. Also to answer to Matteo asking in chat. So we have this report available. The link was also sent to you via the email and was included in the webinar invitation, and it is also Laurent put it in the chat now. So that's the link to the deliverable. This is the public part of the work. We will also make available the recording of this webinar. We will also make available the slides of this webinar. So now there's another question to Antti from Matti Uusipaasto. Antti, if you can see and answer the question, please.
Yeah, in here, Matti Uusipaasto from Caruna is asking that since we used only short-term markets like intraday and MFR, did those markets seem sufficient enough, and should there be longer contracts for DSO needs? Yes, Matti is right. We would like to have also longer time period flexibility that could be reserved months or even years ahead. But also this kind of a short-term flexibility that we tested here is needed for operational purposes. For example, when there is a unexpected fault in the network, then we need flexibility very fast. And for this kind of situation, the MFR is good. But for other kind of needs, like for example, investment deferral, we would of course prefer long-term flexibility.
Yeah, that's true. And also in the OneNet project now, beside what we call their real-time active energy product and short-term active energy product, we also plan to implement long-term products and two kinds of long-term products. One maybe more applicable for the DSOs, the distribution system operators, and the other maybe more for the TSOs. But of course, both products can be used by both. So we don't want to discriminate any buying party nor any selling party depending on the type of the product. So that's also being settled. I think we can conclude now. I hope to get engaged with many of you in the follow-up activities beyond the interface project. As I said, it's not the end. It's just the start, or let's say a bit more than still a start of the journey. But there we go, and we really need you also, even if you are not formal partners of those projects, because we need to test the solution, we need to demonstrate it to see if it's feasible. Otherwise, I wish you a very good weekend. Enjoy the winter. Enjoy the snow if you have got some already. And hope to see you soon again. Goodbye.